let me introduce you to Salima Alia Katali. She is a cybersecurity engineer at Singapore's iTrust Center for Research in Cybersecurity. Her focus is on performing cyber-physical attacks, and I can assure you of my conversations with her, she knows a lot about that, and she burns for cyber attacks against utility ranges and environments and learning all about this. So it is great pleasure for me to announce her as the next speaker. And as I said, there couldn't be a more timely talk than hers. Salima, the floor is yours.
Hello, thank you, Kai, for the warm introduction. So I will begin my presentation now. My name is Salima, and I'm a cybersecurity technology engineer from iTrust. And today I'll be sharing with you the tactic, techniques, procedures from our ICS Cyber Range event. Yeah, so before I go through the more juicy part of the content, let me briefly explain what is iTrust and what we do. So iTrust is a research center. We are based in a university called Singapore University of Technology and Design, SUTD. And our focus area is research on cybersecurity pertaining to cyber physical systems and in IoT. We also provide training to both internal and external parties. So we actually have some collaboration with other agencies to have training in this area. And also internal, where we have a postgraduate course called Securing Cyber Physical Systems. So we actually train students to have more knowledge in this field. And obviously, we conduct cyber range exercises, which is what I'll be sharing with you today. The distinctive value about us that set us apart is we focus more on applied research instead of theoretical. And we are proud hosts of 4 testbeds, which I will share with you later on the slides. In iTrust, we have a lot of talented people. So whenever there is a problem, we usually come with a multidisciplinary approach instead of a single discipline. And since it's an academia setting, we work with a lot of students, including undergraduates and postgraduates. And due to the nature of our research itself, we work with a lot of industry collaboration as well. So this is the testbed that I was mentioning about earlier. So let me bring up my pointer real quick. Yeah, here. So in iTrust, we have 4 testbeds. The first is IoT automatic security. So this is actually a shielded room inside here where researchers can conduct experiment in an enclosed environment and without much interference to the outside network. Secondly, we have EPIC, which stands for Electric Power and Intelligent Control. So this is our power testbed. So this testbed has power generation, transmission, and smart home. Thirdly, we have WADI, which is the water distribution testbed. And fourthly, we have a secure water treatment testbed, SWAT. So this testbed was very heavily utilized. So this is where the ICS Cyber Range event occurred. So the cool thing about these 3 testbeds, which is more related to ICS, they actually can be connected. So you could supply power through this testbed, and in turn you treat the water and then you distribute the water. So what happens when a water system got hacked? So you can see there's photos above here. These are actual incidents that occurred in our lab, actual flooding incidents. So there's been case where researchers forgot to turn off a certain attack or basically didn't attack to cause flooding. So there are a few cases where our whole lab got flooded. As you can see, water being spilled out and coming out of the lab to the control room as well. So flooding of tank is one attack scenarios that we observe in the water treatment system. So CISS. So this is the Cyber Range event that we're talking to you about. CISS stands for Critical Infrastructure Security Showdown. OL stands for online. This is iTrust's 4th installment of technology assessment exercise. It was conducted over 2 weeks in July 27, from July 27 to August 7 in 2020. So we invited red teams and blue teams to attack and detect respectively. The previous exercises were held physically. So we actually flew red teams down to our lab and ask them to attack the infrastructure. But because of COVID, this wasn't possible. So it was a challenge for our team, but nevertheless, we brought this whole system online. And thanks to the power of digitalization, we managed to have many red teams from different countries. So we have team from the US, team from the Netherlands, from the Finland, from South Korea, and also teams with different backgrounds. So we have teams that are actually that provide professional red team service, and we have team from the government agency, we have team from the industry itself, and also from the academia. So CISS is more like a competition style with for red teams to see how they attack this infrastructure and how they fare. So this give hard to get insight to red teams and hands-on experience to approach this critical infrastructure, which in turn will be beneficial for us as the committee to how to protect this system as well. So the arena. So I'm not going to talk to you about the playground, the arena itself. It consists of three major components. So the first one is we have the corporate network. Secondly, we have the demilitarized zone. And thirdly, we have the SWAT test bed, which is the physical test bed. And they're all connected via a firewall here. So typically, if a red team want to compromise the operation side, what they have to do is they have to traverse the network from the corporate network all the way to the DMZ zone and then to the SWAT network. So Zycross Cyber City. Zycross Cyber City is our corporate network. We call it Zycron Cyber City. So when the red teams come in, we put them in this corporate network, and this corporate network is a full-fledged network. So it consists of servers, CCTV, network printers. There are about 150 virtual PCs there. There are also user terminal accounts to mimic employees. And there are roughly about 10,000 IP in this Zycross Cyber City. So this mimic actual enterprise system like what you would see outside. Okay, secondly, I'll go through our SWAT test bed. Like a SWAT is an actual physical test bed, and this is the screenshot of our SCADA system. So in SWAT, we have 6 stages. So I'll briefly walk you through what are those stages. Firstly, we have our raw water stage, which consists of the motorized valve, the tank, and the pumps. And then when the water comes in for treatment, for this treatment process, it goes to this stage 2, which is the pre-treatment stage, which consists of chemicals. And then it goes to stage 3, ultrafiltration over here. And then it goes to stage 4, dechlorination stage. So this is the UV dechlorinator. Fifthly, we have our reverse osmosis stage here. So this is the RO membranes. And the final stage, stage 6, is our RO product. So this is the final stage here. Okay, so the gameplay. So how did this game was carried out? So for this event, we had 17 red teams with a maximum of 6 players. So each red team were given 4 hours of gameplay. So these 4 hours comprised of 1 hour in the IT environment and 3 hours in the OT environment. So after 1 hour, we actually gave the red teams the option if they want to teleport to the OT environment itself. So this is because we were more interested in the OT side. We also asked the red team to share their screen. So we have an attack logger that logs the red team's every move. So if you look at this picture here, this is actually the screen of our attack logger. And this is the screen of the red team. So whatever action that the red team were doing, it was being locked down. So one of the logs we could see was nmap scan on this particular IP. We also asked the red team to inform us of what they're gonna attack, especially in the OT side. So we asked them the intention of the attack, the targeted component, and how is this attack carried out. The reason being is this is an actual system. So if it's free for all, it will cause a detrimental effect in the system itself. Okay, so traversing the network. How do red teams typically or could traverse the network? So like I mentioned, there are 3 components to this gameplay: corporate network, the DMZ zone, and the SWOT network. So the red team starts from the corporate network. There are actually special services that could be exploited that enable them to traverse to the DMZ zone. And in DMZ zone, there's actually an FTP server, which then can be exploited, which further enables them access to the OT zone. And once you are in OT network, you could find ways to damage processes. With that said, actually now the team successfully managed to compromise and penetrate the network. This is because the gameplay was only 4 hours. It was quite short, and a lot of teams wanted to teleport to the OT network. Nevertheless, there were a lot of teams that were very, very close to compromising. Perhaps with a longer duration, they could have penetrated through the network. Okay, so from this point on, I will only be focusing on the OT side. So once the team comes to the OT network, either by teleportation, when I mean teleport is we actually physically unplug them from the IT side and plug them to the OT side. So from there, this is what we observe. So this is how red teams do their attacks, and they're trying to make process changes that are affecting the PLC, sensors, or actuators. So what we notice is attacker, the red team, use some enumeration method to compromise the GUI, HMI, or SCADA, or the engineering workstation. So if a red team compromise the HMI SCADA, since it's a GUI, they attack via GUI and then in turn cause changes to the PLC, sensors, and actuators. If the red team managed to compromise the engineering workstation, this is where the PLC code happens to be, they can attack via the PLC code, maybe make some modification or upload a new malicious code, which in turn affects the PLC, sensors, and actuators. And we have a small team of insider. So this is the internal team. This team was responsible for launching attacks to validate the blue team. So the purpose was to see how blue teams fare in this and these attacks. You also can see there's a direct arrow between attacker and attack by script. So when we plug them to the OT network, we plug them to this particular system. From the system, they could actually launch their attack script, which caused changes in sensors and actuators, but a lot of them weren't aware of this. They thought that they have to compromise the HMI SCADA or the engineering workstation. So they decided to compromise this first, and then they launched their attack script. So some teams that they were aware of it, they found out by some other means, they decided to just launch their attack from where they were, that which in turn affects the sensors and actuators. Okay, so now I'll explain some example of how a red team compromised the SCADA workstation. So like typically, what you need to do is first need to know the IP of the SCADA. So the red team identified the IP. They found out that the SCADA workstation was a Windows 7 PC, and that could be exploited via Eternal Blue. So they exploit the system by Eternal Blue, and from there they use a mimic tool to get the credentials. And once they got hold of the credentials, they connect to the system via RDP, and from there they have access to the GUI. And once you got access to the GUI, you pretty much can do a lot of things to this plant. So another example, the previous example was about using mimic tool. This time around, the red team used net user in Meterpreter. So similarly, the team identified the IP. They exploit this system via Eternal Blue exploit. They use net user in Meterpreter to get the credentials. And once they got hold of the credentials, they connect via RDP. So this team did a step further. They actually log out the actual admin by changing the password. So now the actual engineers there were unable to log into the system. And then they control the SWOT through GUI, which in turn, they can make a lot of damage to it. So another example, exfiltrating of files. So similarly to mimic tool and net user, this team did by exfiltrating files. They identify IP. Similarly, they exploit the system via Eternal Blue. they exfiltrated files, and this time around they added a new user, a new privileged user. So they use this user credentials to connect to the RDP to the system. And once they connect to RDP to the system, they log out the admin by changing password. And from there, they got hold of the SWOT GUI, and then in turn, they could cause changes to the process. So apart from Eternal Blue exploit, we also saw one team, they use BlueKeep exploit. So BlueKeep is an exploit of Windows RDP endpoint. So like similar to what you saw earlier, Eternal Blue, but this time around it was BlueKeep. So the screenshot here was actually taken from the red team. The red team used the MSF console to carry out this attack. Enable write access on HMI touch panel. So this is a attack that we saw in our ICS event. So in SWOT testbed, there's this HMI touch panel inside the lab itself. So this touch panel is mainly for your viewing purpose. There isn't any like write authentication to it. So this team, they actually found a vulnerability on this touch panel. So they use a ZAP web application scanner. They use it on the HMI touch panel, discovered that a vulnerability of write authentication equals to deny option. And this option, they were able to change this option. So they changed it to allow. And now you have write authentication on the HMI panel. The attacker decided to, okay, I'm just going to shut down the plant. And they actually managed to shut down the whole plant. So if you look at the screenshots here, initially it was write authent equals to deny. And then they changed this to allow. So it was write authentication equals to allow. So this gives them full access of the HMI with writing privilege. And the team decided to shut down the whole plant. Okay. Packet injection. So one of the more common attacks that we saw is packet injection attack. So this was mainly done using Python, particularly PyCom and PyLogic libraries. So PyCom and PyLogic are a collection of modules that can be used to communicate to the PLC, particularly Allen Bradley PLC. So in SWOT testbed, the brand of PLC we use is Allen Bradley. And with this package, you could actually communicate to the PLC directly if you know what the IP address of the particular PLC is. So PyCom supports Python 2, and the newer one, PyLogic, supports Python 3. So this has more additional functions as well. Okay, change via GUI. So initially, I share with you some examples how red team managed to compromise the GUI, like from compromising the SCADA. So what really happens when this red team compromises SCADA? So these are things that we notice. So they actually try to change the actuators or the sensor value. When I mean change the actuators is they want to turn a certain pump on and they turn it on, or they want to close a certain valve to block the outflow, they close the valve. And change the sensor value could be changing the level of the tank or the sensor reading itself, or the chemical sensor reading itself. Another thing one red team did was they changed the set point. So if you look at this picture here, this is the screenshot taken from our SCADA. So LIT 101 stands for Level Indicator Transmitter Stage 1 first tank. So over here, you could see there are alarm set points for high, 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 low, and low, low. The high is at 1000, the high is at 800, and if you notice, the low is at 0. This was not the original value. This was actually being changed by the attacker through the GUI. And obviously, once you got hold of the GUI, you could stop the plant, like what you saw with the team that managed to compromise the touch panel itself. Double dose of sodium hypochlorite. So I will share with you some examples of attack scenarios what this red team did. So one of them is adding more chemical to the tank itself. So sodium hypochlorite is actually the same component of the same chemical that was in the Osma, Florida incident. This is more of an automation of the SCADA hijack attack. So what this team did was they decided to add more chemicals to the plant itself. So in SWOT, we have two pumps for one purpose. One is the main operation pump, and the second is the redundancy pump. So if the main one fails, the second one take over. So this team, they decided to turn on both pumps, which in turn caused double dose of these chemicals to be fed into the test bed itself. So this, you actually could see increase of the chemical sensor reading. So I briefly walk you through this code here. So this was done using PyCom, like what I mentioned earlier on. So you're talking to the PLC directly. This is the PLC IP. And this, you can notice here, read tag and write tag. So this read tag is reading the sensor reading, chemical sensor reading. And write tag here is they're trying to make turning on the pump. So if you can notice here, P205, P206, which is the pump dot auto. Initially, it was in auto mode. They set it to manual. So it set it to 00. And then they turned on both pump, P205 and 206. They turned it on. So CMD stands for command. Okay, one way you could make this attack more stealthy, which we have observed before, is not only do you turn on the chemical pumps, you could also spoof the sensor reading itself. So if the sensor reading is spoofed, it's very hard to very hard to detect. Flooding of tank. So another attack scenario, flooding of tank, like what I showed with you with all the pictures above before. So flooding of tank, there are two ways to do. So one is you could change the level sensor. Another way is you could change the actuators itself. So this team used the approach of changing the level sensor. So what the team did was they wait for a particular tank to reach on a high or a high level. And once it's very high, they spoof the sensor reading to something that's low. So now that the PLC thing is, oh, this particular tank is low, I need to pump more water to it, and then it open up the pump to fill up this tank, which is already high. So over time, this will cause an overflow and eventually flood. So there were a lot of attacks. There were a few attack scenarios using during the event. A few of them attempt this attack. So thankfully, we managed to stop this attack before it caused an actual flooding. But there was a case where the tank was already water was already leaking out of the tank. But thankfully, no flooding happened that day. Changing their PLC code similarly to the attack before, a flooding of tank. This is they're trying to achieve the same objective to flood the tank. So I mentioned there's two ways you could do. One is you change the sensor reading. Another one is you could change the actuators. So in stage one of SWOT test bed, it consists of a motorized valve here, and then a middle we have the tank, and at the end we have a pump. So to flood the tank, what you could do is you could block out the outflow. So you turn off the pump and you increase the inflow, you open the valve. So this will cause an increase in water level. So this is what the team did, but they use it they try to achieve this using PLC code. So if you look at the first part of the code here, what this team tried to do is they actually set the motorized valve and the pumps to manual mode. And once they got hold of the pumps and valve in manual mode, they are able to control it. Bit in the middle. Okay, bit in the middle is a very highly sophisticated attack. In fact, this is my personal favorite attack, I would say. So in iTrust, I spent quite a number of time coming up with different attack scenarios, coming up with different attack vectors, and a significant amount in level 0 network, trying to launch attack in level 0 network. But this attack was something new. I didn't know this was able to be done. So it was very interesting, hence my personal favorite, I would say. So I'll walk you through what this attack does. So similarly like a man in the middle, this is the bit in the middle. So it's the attacker inserted a malicious tag, a bit into the PLC within itself. So now this caused direct communication between the PLC, between the RIO and the GUI, SCADA HMI. So this bit blocks the particular routine from execution, and values are not being updated to the HMI tag. So whatever you see in the GUI are not being updated. Then the attacker then use a PyCom script, a Python script, to launch this, to change the value of at level 0 by turning on the pump and change the conductivity sensor. So I will explain in more detail in this screenshot here. So when I say bit, this is what I mean. So this RU_BY, this is what the red team inserted, malicious tag. So there's two parts to it. First was taking hold of the PLC ladder logic. So if you are not familiar with this, this is PLC ladder logic, which runs the PLC program. So this is the bit that's inserted. So once this bit is inserted, this whole thing will get executed. So this is the first part. And the second part is using the PyCom script. So similarly, it's using PyCom, talking to the PLC directly. This is reading the chemical sensor. Over here, write RU_BY. This is writing to this tag. And once he wrote to this tag, he was able to write to, he could write to the level 0. So this is DO_P_201_ This is the tag in level 0. DO stands for digital output. So he set it to 1. He also set the redundancy pump to 1. And then after that, over here, he decided to set the conductivity to 4000. So AI_AIT. AI here stands for analog input. So this attack is highly sophisticated. It's very similar to Stuxnet, similar in a sense where whatever is happening in the physical side is not being reflected to the GUI. So in the GUI, you see that you can see that the pumps are actually not turned on. But when you go to the SWOT test bed inside at the stage 2, you see that the pumps are actually in fact turned on. They're just not being reflected to the SCADA. We know that level 0 attacks are very, very hard, and also most intrusion detection mechanisms are from level 1 and above. So this kind of attacks are very, very hard to detect and could be easily go under the radar. This second attack, bit in the middle. Similarly, the attacker inserted RU_BY bits to almost all of the rugs before each routine. So this resulted in the RU values from the PLC2 for not being transferred to the HMI. So accurate readings were not being updated to the historian itself. So he just wrote this single line, write tag RU_BY to disrupt all the sensor variables. So when I mean by insert to almost all the rugs is here. So instead of putting for one, he inserted for everything. Yeah, so in conclusion, so we noticed that damages to process are mainly done by 4 ways. So firstly, by the GUI, either through HMI or SCADA, or the secondly is by changing of PLC code or uploading new malicious code. Thirdly is via the attack script, which we saw using PyCom or PyLogic. And fourthly is by a malware, which is more towards the insider team. We also noticed that red teams have a better understanding of the OT system, tend to perform better. So there were some things that once they managed to compromise the SCADA or HMI or the engineering workstation, they weren't really sure how to proceed or what to do to cause a process anomaly. But the teams that were very, very good understanding of the system, they were like, okay, I'm going to cause disruption in this stage. To do this, I need to know A, B, C, D. They were very direct and to achieving their objective. Thirdly, transferring from the IT to the OT network is not that straightforward, but doable. Like what I mentioned, none of the team actually managed to successfully penetrate through the network, but they were very, very close. So perhaps with a longer time frame, they could have successfully penetrated through the network. And lastly, new attack vector bit in the middle. This was something new for us. So all the other attacks we were actually familiar with it, be either from our own internal research team or from our previous exercise. But bit in the middle was something new and we didn't see it before. Okay. So towards the end of my presentation, I highly recommend everyone to go download our official report. So in this presentation, I only shared like very few examples of attacks. If you want to know the whole list of attacks, what each team did, how they fared, how were the scoring made, how were blue teams fared. Yeah, highly recommend to download our official report. If you're also interested in a previous event, the report is also in our website for 2019, 2017, and 2016. Yeah, so CISS 2021 is going to come soon. This time around, we are in the early stage of planning. It's going to be bigger, better, more fun. The arena is going to be bigger, so you could see we're going to have a new corporate network, corporate DMZ zone, a World Wide Web. And the best part is we're going to incorporate a new test bed, water distribution test bed. So this test bed is the first time we're going to incorporate into the cyber exercises. So we are quite excited to see what type of attack scenarios red teams come up with. Yeah, thank you everybody for your time. Yeah, and thanks this community for having me, and also thanks everyone for your contribution in making our critical infrastructure safe. Thank you.
Thank you very much, Salima. I mean, especially with that, again, the bit in the middle attack, if you don't go boom, mind blown with that one, I don't know what will make you turn your head upside down from the audience. So a few questions. Before I go to the questions from the audience, I'd like you to maybe give a little bit more elaboration on what information did you provide to the players in that cyber range exercise of the environment?
Okay, so we told them the playground. So it consists of the corporate DMZ and the SWOT test bed. We didn't share any IP. We shared how the process works. So they were familiar with the 6 stages and how each process works, and that's about it. Yeah, we didn't share much information to the team. So the IPs of those in the IPs in SWOT test bed were actually people found it through enumeration method. Yeah.
Thank you. Did you provide them with the project files for the PLCs, or did the attackers, the players, have any insight into the PLC programming?
No, so they compromised the workstation, and then they got hold of the PLC code, and from there they do whatever they wanted to do. Yeah.
Thank you for that elaboration, because that is exactly real world. I mean, because there was a question, or more of a statement, that, yeah, number one, PLCs have to be in programming mode to do these changes, and yeah, you need to know the programming logic. I can remember a few very high-profile cases out there in the real world, like CISS being one of them, where the PLC, in this case an SIS, was actually set to the program mode and not the run mode, as it should be in the real world. So we should never assume that everything is going as it should be by the book. And also, exactly as you said, yeah, the programming is on the engineering workstation, which is why these are one of the prime targets of any adversary into an industrial environment, because that is where you learn how the programming looks. One other question that was posed from the audience: did you map the attacks that you simulated in that range to MITRE ICS attack matrix?
Sorry, MITRE ICS? What do you mean?
Yeah, the question was, did you map the attacks that you simulated to MITRE attack?
Oh, no, I didn't. We didn't, yeah.
Thank you. And another question, and I know we're 2 minutes over, so I'll let you in the break real soon. Were there any CCTV cameras in your range, and did you ever see them being leveraged as a pivot into the ICS environment?
There were CCTV cameras, but it wasn't part of the range itself. Yeah, not in the OT set, but there were, yeah.
Thank you for that. So thanks again, guys. The parting words I want to give you about this talk, and why I, again, really recommend you download the PDF and look into this, is exactly what Salima said. Her favorite attack was the bit in the middle, because it took me like 2-3 times to walk through the slides to really understand this. And I've been doing this for too many years, I care to mention, because this attack very well shows both sides of of the coin when it comes to ICS. I mean, number one, the way you need to think about PLCs and how these processes and this programming works and the rungs with ladder logic and deterministic processes. So you need to have an understanding how to jump into that process, but also, and this is the side that ICS folks need to learn, at the end of the day, these are commands in a transformed programming language. So why not jump in there and change something? But only if you take these two approaches together and understand how they actually interact, these two different views of the world that is ICS components, this is when this finally starts making sense. So thank you for this, because I think, frankly, this was to me the mind-blowing aspect of you. So I fully agree with you. This is really, really cool. Thank you, Salima.
I was a bit surprised myself when I see this being launched.
Absolutely. I mean, this is one of the things, like, this is conceptually another level. So if you finally wrap your head around how this works, exactly like you mentioned, this just opens a whole nother realm of what could be possible once you start wrapping your head around it. So guys, I highly recommend you follow up with that with Salima in her hallway.